All right, I'm going to cover establishing the loads on an interior beam in this video. And so when we have an interior beam, we're talking about specifically these beams in the middle here are all interior beams. And we're going to have to establish the tributary width and then determine what our design load or our loads are going to be based on the criteria here. And so I specifically want to call out the dead load and the live load of dead load is 50 pounds per square foot, and the live load is 100 pounds per square foot. So if I look at this image here, I have an area on this beam that if this is my beam here, and I'm looking at that beam right there, and I go halfway between this beam there and the next one below it here, and look at that tributary width. I'm going to actually draw this a little bit larger so that I can do this. Okay, so this is this area here blown up over here. So this is the beam that I'm going to focus on, is that interior beam. This beam from here to here is 6 feet 8 inches from each other, and the same thing down here. So I have 6 foot 8 inch spacing. I'm going to convert that to feet right now. So that's 6.66 feet total. That's in between here. So as I go from my beam towards this next beam, I'm going to go halfway. So I'm looking at 3.33 feet this way across. Because if I go over here into this space over here is going to be supported by this beam in orange. And this base that I'm going to highlight in red once I get all done is going to be supported by our interior beam. So I'm going to go halfway between this beam here and all this area highlighted in red is my tributary area that giant blue beam in the middle, my interior beam, is going to be responsible for holding up. So the tributary width for this beam is halfway between 6 feet 8 inches over here, so 3.33 feet this way, and 3.33 feet this way, for a total of 6.66 feet here for my interior beam. My exterior beam that is in orange here is going to be, this is my beam that I'm looking at, exterior beam, and between here and this orange space is going to be 3.33 feet. We're going to work on the interior beam in this video, so I'm looking at the area highlighted in red to start off, and that's going to have that tributary width of 6.66. So now now we have our tributary width set up, now we can figure out how much is this blue beam going to have to hold up per foot. So I'm going to take this slice, I'm going to do this part in green. This is going to be per foot. I need to figure out how much does this area of the beam weigh per foot as I go this way. So if I'm looking at my tributary width is 6.66, and each square foot in this green area weighs 150 pounds. My design load, or my loading on this is going to be, load is equal to the design load times the tributary width. Alright, so my design load from this slide, and this piece of given information, my dead load's 50 pounds per square foot, my live load is 100 pounds per square foot. So my design load here is 150 pounds per square foot times 6.66 feet. My load on this beam in this green area is equal to 1,000 pounds per lineal foot now. Notice that this is 6.6 feet here. I'm going to get my square feet, I'm going to cancel one of those out, and I'm going to be just left with pounds per lineal foot. So this green area is how much this beam is going to have to hold up per foot. If I want to figure out how much this beam is going to have to hold up the entire way, I know that this is going to be an 18-foot beam from my diagram over here, and this whole beam would have to hold 18,000 pounds. Not really something we need to know at this point. The next step is to put this into MD solids and calculate the end reactions. How much is this beam going to have to hold up at each end? So check out that video as well. That's all for establishing the loads.